Good morning class once again. So let us continue with what we were doing earlier. As we all know, we are taking up equation of straight line currently, and we have discussed the slope, we have discussed y-intercept, we have discussed the different forms of equation of straight line, including the point slope form and the two point form of the equation of straight line. Now, as I had mentioned, if you remember in the previous lecture, that in the next lecture we will be discussing the condition of parallelism and perpendicularity of lines. That means what happens if two lines are running parallel to each other. So what is the relationship between their slopes and so on and so forth. Similarly, if two lines are perpendicular to each other, that means at 90 degree to each other, then what will be the condition as far as the slope of the lines are concerned. Okay, so if you see over here, I have listed down for parallel lines. Okay, so for two lines which are running parallel to each other, obviously you can understand this by simply drawing a rough diagram like this and like this. So if suppose that these two lines are the parallel lines, okay, these two lines are running parallel to each other, so obviously you see that the angle that they are going to make with the positive side of the x-axis, these theta angles, they are also going to be same. Okay, so if these thetas are same, then obviously tan theta value will also be same, and tan theta is nothing but the slope. Okay, so for any two parallel lines, suppose these two are the parallel lines and their slopes are let's say for example m1 and m2, then if they are parallel, m1 and m2 will be same, or they will be equal. Okay, so now onwards you will always remember, for parallel lines the slopes are equal or same. Similarly, for perpendicular lines the condition is m1 will be reciprocal of the other slope, which is m2, and with a change of sign. Okay, so you can write m1 is equal to minus 1 upon m2, or you can also write m1 into m2, the product of the slopes will be equal to minus 1. Okay, so if you see, this m2 can go this side, cross multiply, so you will have m1 into m2 is equal to minus 1. Okay, so this is the condition for parallel lines, this is the condition for perpendicular lines. Okay, now the proof of this is not in your syllabus, but then the application of these things will be there as far as the questions are concerned. So we'll go straight forward to the questions. Question number 1, if you see, we will start with the basic questions first. Show that the lines, this one and this one, are parallel. Okay, so immediately if you have to show that two lines are parallel, you simply have to show that their slopes are equal. Okay, so we have to prove that. Okay, so first of all, the very first thing that we will have to do is, in this line and in this line, we will have to find their slopes. Okay, if their slopes are coming equal, then that means they are parallel. Okay, so let us take the first line for example first. We have x plus 2y minus 5 is equal to 0. In order to get the slope from this line, we will bring this into the y is equal to mx plus c form. Okay, so for that I will keep 2y on that side, on the same side, and we will take the other things onto the right side. So x goes to the other side, it becomes minus x, minus 5 goes to the right side, it becomes plus 5. Similarly, now in the next step, remember, we have to bring this equation into y is equal to mx plus c form. Okay, so on the left hand side we need to have only y, but here we have 2 multiplying y. So what we will do is, we will divide this side by 2, so we will have to divide this side also by 2, so that we do not make any change in the original equation. Okay, so once we divide both sides by 2, this side, this 2 and this 2 gets cancelled, so you have y is equal to minus 1 by 2 x plus 5 by 2. Okay, so similarly I have divided minus x by 2 once, so we get this, and then plus 5 by 2. Okay, so this is the equation that is now in the form y is equal to mx plus c. Okay, so immediately you can write down below that y is equal to m1x plus c1. Okay, because this is the first equation that I have taken, so I have taken m1 and c1. Okay, now when you compare, you will see that your m1 is minus 1 by 2. Okay, so I will write m1 is minus 1 by 2. Okay, so the slope of the first line we have found out. Similarly, we will find out the slope of the second line, which is 2x plus 4y plus 9 is equal to 0. Again, we will have to express this in the same form, y is equal to mx plus c form. So we will keep 4y on this side. The other two things will be taken to the right side, so they will become minus 2x minus 9. So we will divide this side by 4 and this side also by 4. Okay, why? Because we need only y on the left side. 4 and 4 gets cancelled, so you have y is equal to, again individually I will divide minus 2x by 4, so that will become minus 2x by 4 and then minus 9 by 4. So we have y is equal to, now you see this 2 and this 4, they get cancelled to get minus 1 by 2x minus 9 by 4. Okay, so now is this equation in this form now? Yes. Y is equal to mx. So now again I will write y is equal to, this time I will use the symbol m2 x plus c2, because this is for the second line that we are talking about. Now when you compare again, you will see that your m2 is also coming out to be minus 1 by 2. Okay, so you see this slope and this slope, they are equal. Okay, and what was your question? Show that the lines are parallel. So what was the condition for parallelism? Slopes should be same. They are same. Therefore, you will write, since slopes are equal, therefore the lines are parallel. Okay, so you have proved this question by finding out the slopes of the two lines and showing that they are equal. Okay, now let's go on to the second question. Okay, so here is your second question. If the lines this and this, so again two lines are given, are perpendicular. So they have told you that these two lines are perpendicular to each other. That means they are at 90 degree to each other. They are cutting across each other at an angle of 90 degree. Find the value of p, small p. So if you see over here in the second equation, there is an unknown p, small p, which you have to find out. Okay, and what will be the basis of the solution of this question? The basis will be that these two lines are perpendicular to each other. So if they are perpendicular to each other, you simply write down for perpendicular lines. This is the sign for perpendicularity. For perpendicular lines, you have m1 into m2 is equal to minus 1. This is the condition that we have for perpendicular lines. So now our only thing that is left for us to calculate is the values of m1 and m2, which are the slopes of these two lines. Okay, so take the first line for example, y is equal to 3x plus 7. There is hardly anything to be done here because this is already in the form y is equal to m1x plus c1. Okay, so no changes required. Straight away if you compare, you will see that the first slope is 3, or the slope of the first line is coming out to be 3. Similarly, for the second line, you have 2y plus px is equal to 3 is the second line. Here slight modification is required, so we will bring this equation into y is equal to mx plus c form. 2y is equal to, I will take this to the right side, it becomes minus px plus 3. Since we need to have only y on the left side, we will divide this side by 2 and this side also by 2. So you have 2 and 2 getting cancelled. So you have y is equal to minus p by 2x plus 3 by 2. Okay, so this is now in the form y is equal to mx plus c. So I am going to write y is equal to, now since this is the second equation, so y is equal to m2x plus c2. Now when you compare, you will see that your m2 value, which is the slope of this second line, is coming out to be minus p by 2. Okay, this is the second slope. Okay, Now we already know for perpendicular lines m1 and m2 product is -1. So therefore we will see m1 into m2 is equal to -1. So we have m1 value as 3 and m2 value as minus p by 2. So this is equal to -1. Okay, so you multiply this, you will have minus 3p by 2 is equal to -1. Minus and minus gets cancelled. 3p is equal to, now this 2 goes this side, it multiplies, you have 2. So p becomes equal to 2 by 3. This is your answer. Okay, so this is your answer. You had to find the value of p. P is coming out to be 2 by 3 according to the condition of perpendicularity. Okay, so here is the third question in the based on the same topic. Find the equation of a line. Okay, so this time we are going to find the equation of a line. Okay, remember we have already discussed 3 different forms of the equations of straight line. We have y is equal to mx plus c. Then we have y minus y1 is equal to mx minus x1, which is the point slope form. And then we have also discussed 2-point form. Okay, so let us see which case will be applicable here. Find the equation of a line parallel to this line. Okay, so that's the first information that we have. Our line is parallel to this line. Which line? This line. Okay, so that means immediately what comes to our mind is, whenever 2 lines are parallel, their slopes will be equal. So whatever is the slope of this line will be the slope of our line also. Okay, so we have 3x plus 2y is equal to 8. I am going to bring this into the y is equal to mx plus c form. So you see I am keeping y on one side and everything will be taken on the right hand side, everything else. So divide this by 2 and divide this by also by 2. So this 2 and 2 gets cancelled. So you have y is equal to minus 3 by 2x plus 8 by 2 is 4. Okay, so we see that the slope of this given line is minus 3 by 2. Okay, so we will write, therefore slope of the required line will also be equal to minus 3 by 2. Why? Because the lines are parallel. Okay, so what we know now is the slope of our line. Okay, so if we can get to know one point through which this line is passing, then we can apply the point slope form. Okay, because slope we already know. If we can get one point, our job is done. So read the remaining part of the question. And passing through 0, 1. So we already know a point which is 0, 1. Okay, so we can call this as x1, y1. If this is the point through which the line is passing and this is the slope of that line, we can immediately apply the point slope form. So we have y minus y1 is equal to mx minus x1. This is the point slope form. Okay, this is the point slope form that we are applying. So y minus y1, so y1 is 1 equal to m is the slope, we have already found out the slope, minus 3 by 2, and then x minus x1. x1 obviously is 0, so you actually don't have to write anything, you will simply write x. Okay, this 2 can come this side and multiply, so you have 2y minus 2 is equal to minus 3x. Okay, so this can be taken to the left hand side, you will have 2y plus 3x minus 2 is equal to 0. This is the required answer. Okay, so like this there are different forms of questions that we will have to do. Let us move on to the next question. Okay, so let's continue with the next question. We have find the equation of a line passing through the intersection of the lines this and this. Okay, so our line is passing through the intersection of 2 lines. Okay, so whenever 2 lines intersect, I'll show you in a rough diagram like this. If these are the 2 lines that are intersecting each other, that means they are cutting each other. So there is going to be a point of intersection. Okay, so there is going to be a point of intersection. Okay, so that point P can be found out by solving these two equations together. We already know the process. So let's have 5x minus 8y is equal to minus 23. Okay, this is the first equation that we have. See, this and these are the two equations that we have. So this is equation number 1, and similarly you have 7x plus 6y is equal to 71. If I take minus 71 to the right side, this is the situation that we have. So this is equation number 1 and this is equation number 2. Their point of intersection has to be found out. So we will have to solve them simultaneously. See, this can be multiplied by 7 and this can be multiplied by 5. Okay, so 7 5s are 35x minus 7 8s are 56y is equal to 7 gets multiplied here also. So you have 7 3s are 21, carry 2, 7 2s are 14 and 2 16. Okay, so this is the equation, modified form of the equation once we multiplied the first equation by 7. Similarly, the second equation by 5. So 5 7s are 35. This is basically the reason why we multiplied by 7 and 5, to make the coefficients of x as same. So we are going to use the elimination method to solve this. 5 6 are 30, y is equal to 5 into 71. So 5 1s are 5 and 5 7s are 35. Okay, so these are the two forms of the equation that we have got. Now obviously we have to subtract. We can see that we have to subtract. So 35x minus 35x, they get cancelled off. Minus 56y and minus 30y will make it minus 86y is equal to, obviously, minus 161 and minus 355. When they get added, we get 5 and 1 6, 6 5 11, 3 and 1 4 and 1 5. Okay, so minus and minus gets cancelled. You have y is equal to 516 divided by 86. Okay, this gets cancelled straight away. You get a value of 6. 6 6 are 36, carry 3, 6 8 are 48 and 3 51. So we get a y value of 6. Now this y value of 6 can be put in any one of these two equations to get the value of x. Okay, so let me write over here in equation 1, that is the first equation. So 5x minus 8y, 8 into y, so 8 into 6, so I'll write that directly. 8 6 are 48 is equal to minus 23. Okay, therefore 5x becomes minus 23 and this minus 48 goes to the right hand side, it becomes plus 48. So you have 5x is equal to 48 minus 23, so you can write that down as 25. Okay, so x becomes 5. Okay, now our point P, which is the point of intersection of these two lines, is known as 5, 6. So the coordinates of the point of intersection have been found out. Okay, so now let us go back to the question. Find the equation of the line. Now which line are we talking about? Not these two lines. Our original line, which is passing through the intersection of these two lines. So this is our line that is passing through. So I'll write this is our line. Okay, now this is only for understanding. You may not draw it as a part of the solution. So this is our line and it is passing through 1 point 5, 6. Okay, so we know 1 point. If we can know the slope, we will be able to apply point slope form. Okay, 1 point is already known. Let us see if we can find out the slope of our line. So our line, if you read the remaining part of the question, and perpendicular to the line this. So there is a third line also, and our line is perpendicular to this third line. Okay, so that means if we can get the slope of this line, we can also get the slope of our required line. Okay, so 4x minus 2y is equal to 3. Now if you have a look at this particular line, we can bring this into y is equal to mx plus c form. So minus 2y can be taken to the right side, so you have 2y is equal to 4x minus 3. After slight adjustment, you will see that we can divide this by 2 and divide this also by 2. So 2 and 2 gets cancelled. You have y is equal to 2 2s are 4, 2x minus 3 by 2. So what is the slope of this given line? The slope of this given line, if you again compare m1x plus c1, so your m1, which is the slope of this given line, is 2. Okay, so what will be the slope of our line? See, remember, in the beginning of this very lecture we had discussed conditions of perpendicularity and parallelism. What is the case applicable in this question? In this question, as you can see, the word is perpendicular. Okay, so that means if this particular line has a slope of 2, then our line will have a slope of minus 1 by 2. Why? Because if you remember the condition, for perpendicular lines, we simply do the reciprocal of the slope and change the sign. So here it was plus, I have put a minus. Here it was 2 by 1, I have done the reciprocal. So this is the slope of our line, and this is one point through which it is passing. So can we now apply the point slope form? Yes, we can easily apply the point slope form. So you write using point slope form. Okay, y minus y1 is equal to m x minus x1. M is this m. Okay, so y minus, now you can treat this point to be obviously x1 y1. So y minus y1, what is y1? y1 is 6 equal to m. Which m? The m of our line. So our line has an m of minus 1 by 2, and x minus x1. x1 is 5. Okay, so this 2 goes this side. You have 2y minus 2 6 are 12 equal to, minus goes inside, so you have minus x and plus 5. Please be careful with the multiplication, especially with the negative signs. So you have 2y, this minus x can come to the left side, it will become plus x equal to, this minus 12 will go to the right side, so minus 12 will become plus 12 and plus 5 will give you 17. Okay, so this is the required answer as far as this question is concerned. So find the equation of the line. This is the equation of the line which was passing through the intersection of these two lines. As you can see, these two lines were intersecting. Our line is passing through the point of intersection. So we found the point of intersection first, and then we use the second part of the question to find out the slope of our line, depending upon the condition. So in this question, they were perpendicular. There can be a question in which the lines are parallel. So in that case, this slope will itself become the slope of our line. And then obviously we apply the point slope form. So that is your answer. Let us now move on to the next question. Okay, so now coming to question number 5 over here. Again a very different type of a question. A, B and C. So these are 3 points that are given. These are the vertices of a triangle ABC. Okay, so the 3 corners or the vertices of a triangle have been given to you in terms of the coordinates. Number 1, find the coordinates of the centroid G, capital G, of the triangle ABC. So this has nothing to do with the your equation of a straight line. Actually, you have to use the formula. If you remember, the centroid of any triangle is a point of intersection of the 3 medians of the triangle. Okay, so if you draw 3 medians from 3 different vertices of a triangle, then they will intersect in the middle of the triangle somewhere. They will intersect at a point. They will pass each other through a given common point. That common point is known as the centroid of the triangle ABC, and that centroid basically has a formula. So that formula is x1 plus x2 plus x3 by 3. This you have already studied in coordinate geometry. Okay, so this first part we will simply apply the formula, and then we have y1 plus y2 plus y3 by 3. Okay, so now the only question that arises is, what are these x1, x2, x3, y1, y2, y3? So you can treat the first point to be x1, y1, second point to be x2, y2, and third point to be x3, y3. Okay, so now we simply are left with substituting the values. x1, x2, x3 have to be added up. So 1 plus 3 plus 7 divided by 3 is the x coordinate of the centroid, and similarly you have 4 plus 2 plus 5 divided by 3 as the y coordinate. Okay, so 7 and 3 10 and plus 1 11 by 3, comma 4 and 2 6 5 11 by 3 again. So your centroid coordinates simply come out to be, you represent it with the capital G. So 11 by 3 comma 11 by 3 are the coordinates of the centroid. Now coming to the second part of the question, which deals with what we are doing in this particular chapter, finding the equation of a line. So find the equation of a line which is passing through this G. Okay, so this G we have already calculated. So this is one point through which our line is passing. Okay, so we will treat this particular point to be the point through which our line is passing. Okay, so we know one point through which our line is passing. Now what is the other information that is given about our line? Our line is parallel to the line AB. Okay, where is the line AB? If you see, okay, let's draw the triangle roughly over here. So if you see A, B, C, if this is the triangle that we have 1 comma 4, we have 3 comma 2, and we have 7 comma 5. If this was the original triangle, and somewhere in between you have your centroid G. Okay, so G, I will not write down over here, the coordinates are already known. So our line is running through G. Read the second part of the question. Find the equation of a line which is passing through G. Okay, so through this point the line is going. Now it can go this way, this way, this way. How do we know? Read the remaining part of the question. And parallel to AB. Where is AB? This is AB line. So our line has to go somewhat like this. Okay, our line has to go somewhat like this, so that it is running parallel to the line AB. Okay, the moment the word parallel comes, we immediately know that the slope of our line will be equal to the slope of the line AB, because for parallelism case the slopes are equal. Okay, so let us find the slope of AB. Same will be the slope of our line. Okay, so where is our line? This is our line. Okay, so for AB, okay, the slope will be, which formula will we use for finding out the slope of AB? AB are 2 points, both points are known. Apply the formula y2 minus y1 upon x2 minus x1. You can treat this point to be x1 y1, this point to be x2 y2. Okay, so y2 minus y1, y2 is 2 minus y1 is 4 upon x2 is 3 minus x1 is 1. Okay, you can do the reverse also. You can treat this point to be x1 y1, this point to be x2 y2, doesn't matter. 2 minus 4 will give you minus 2, and 3 minus 1 will give you 2, so they get cancelled out. You have a value as minus 1. So the slope of line AB is minus 1, therefore slope of our line will also be minus 1. Why? Because they are parallel, given in the question. Okay, so now we know the slope of our line, and we also already know one point G through which it is passing. So can we apply the point slope form? Yes. So using, once again, using the point slope form, okay, you can write y minus y1 equal to m x minus x1. Okay, what is this x1 y1 now? This x1 y1 here now is 11 by 3 comma 11 by 3, because this is that point through which the line is passing, our line. Okay, so y minus 11 by 3 is equal to m is minus 1. Just now we have calculated x minus 11 by 3. Okay, so let us take down the LCM. You have 3y minus 11 upon 3. Once you take the LCM, you will have the LCM as 3 equal to minus 1, and here also you can take down the LCM as 3, so you have 3x minus 11. Okay, so this 3 and this 3 gets cancelled out, so you have 3y minus 11. Okay, 3y minus 11 is equal to, this minus 1 will go inside, so it will become minus 3x plus 11. Okay, so 3y plus 3x, I have taken the minus 3x to the left side, and now similarly minus 11 I will take to the other side, right side, it will become plus 11. 1 plus 11 is already there, so 11 plus 11 will make it 22. This is the required equation of the line that we were talking about. Okay, so this is that line which is passing through the centroid of this triangle, and it is also parallel to the side AB. Okay, so these were some of the questions. There will be one more lecture that will be there as far as the equation of a straight line is concerned. We will do 4 or 5 more complex questions or different types of questions. Okay, the types that are usually asked, even these are the types that are asked in your board exams. So I hope you will be practicing based on what we have discussed till now. Okay, remaining part will cover in the last lecture. Okay, thank you.